Right now, the early stages of El Niño are unfolding across the Pacific Ocean. A vast pool of unusually warm water is spreading eastward, quietly setting in motion a chain reaction that could reshape weather patterns around the world. In past El Niño events, devastating floods have submerged entire communities. Severe droughts have crippled agriculture, and massive wildfires have burned across millions of acres. Scientists around the world are watching closely as the El Niño of 2026 continues its evolution into a full-fledged Super El Niño. The question is no longer whether it will affect the world, but which regions will face its most powerful and destructive impacts. Under normal conditions, warm ocean water is concentrated near Australia and Indonesia. This warm water fuels tropical thunderstorms and heavy rainfall across the western Pacific, creating one of the wettest regions on Earth. Meanwhile, cooler ocean water rises near the coast of South America through a process known as upwelling, helping keep ocean temperatures lower and conditions there relatively dry. During El Niño, this pattern begins to change. The warm water slowly moves eastward across the Pacific Ocean, and the rainfall that normally accompanies it moves as well. Regions that lose this rainfall often become drier and more vulnerable to drought, while regions that gain it can experience heavier rainfall, flooding, and more frequent storms. But the story does not end there. As this enormous pool of warm water releases heat into the atmosphere, weather patterns around the world begin to shift. Storm tracks move, monsoons weaken, rainfall patterns change. Some regions experience floods, while others face drought. The effects begin in the tropical Pacific, but they quickly spread around the globe. The first places to feel the impact of El Niño are often Australia and Indonesia, where the rain begins to disappear. As warm water moves away from the western Pacific, the thunderstorms and rainfall that normally accompany it move as well. The result is often a sharp decline in rainfall across large parts of both countries. For Australia, this can create ideal conditions for drought. Rivers and reservoirs may begin to fall. Farmers often face difficult growing conditions. Heat waves become more likely as clear skies allow temperatures to climb higher during the day. Perhaps the greatest concern is wildfire risk. Dry vegetation combined with extreme heat can create conditions favorable for major bushfire outbreaks. Indonesia faces similar challenges. Drier conditions can increase the likelihood of forest and peatland fires, which can spread rapidly and produce massive smoke plumes that affect air quality across much of Southeast Asia. The 2015-16 El Niño provides a powerful example. Large parts of Australia experienced severe drought, while Indonesia suffered one of its worst fire seasons in years, with millions of acres burned. If the Super El Niño of 2026 continues to intensify, Australia and Indonesia may once again find themselves on the front line of the developing climate event. Before we continue, don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. As Australia and Indonesia lose warm water, Peru and Ecuador gain it. The eastern Pacific is normally cooled by ocean currents that bring colder water to the surface. During El Niño, that cooling weakens. Ocean temperatures rise dramatically, and the atmosphere responds. Warmer water leads to increased evaporation. More moisture enters the atmosphere. Storms become more frequent and more intense. Areas that are normally dry can suddenly experience extraordinary amounts of rainfall. The consequences can be severe, with flooding, landslides, and widespread infrastructure damage. The 1997-98 Super El Niño demonstrated just how destructive these conditions can become. Peru and Ecuador experienced catastrophic flooding that caused billions of dollars in damage, destroyed thousands of homes, and cut off entire communities. These countries sit at the location where El Niño's oceanic impacts are often strongest. If ocean temperatures continue rising during 2026, Peru and Ecuador could once again face some of the most dramatic consequences anywhere on Earth. The heat released into the atmosphere above the Pacific does not stay there. One of the most important changes occurs in the jet stream, the high-altitude river of air that helps steer storms across North America. As El Niño develops, the jet stream often shifts southward. This typically brings wetter conditions to the southern United States, where California, Texas, and parts of the Gulf Coast can experience increased rainfall, stronger winter storms, flooding, and landslides. Meanwhile, northern parts of the United States and much of Canada often experience milder winters with reduced snowfall. El Niño can even influence hurricane activity. Stronger upper-level winds over the Atlantic tend to disrupt developing hurricanes, often leading to fewer Atlantic storms. At the same time, hurricane activity in the eastern Pacific frequently increases. The 1997-98 El Niño demonstrated these effects clearly, bringing widespread flooding and mudslides to California, while Atlantic hurricane activity remained unusually quiet. Although every event is different, North America often experiences some of El Niño's clearest impacts. Few weather systems are more important to humanity than the South Asian monsoon. Every year, billions of people depend on seasonal rains for agriculture, water supplies, and economic stability. Even small changes in monsoon behavior can affect food production across enormous regions. El Niño has long been associated with an increased risk of weaker monsoon rainfall, as shifting atmospheric patterns can disrupt the processes that help drive the monsoon. While drought is not guaranteed, the likelihood of below-average rainfall increases. For countries such as India, the consequences can be significant, affecting crops, reservoir levels, food prices, and water supplies, while also increasing the risk of severe heat waves. The 2015 El Niño highlighted these dangers. India experienced below-average monsoon rainfall, widespread drought concerns, agricultural losses, and growing water shortages. With billions relying on predictable seasonal rains, South Asia remains one of the regions most closely watched during any major El Niño event. One of the most fascinating aspects of El Niño is its ability to produce completely opposite outcomes within the same continent. In East Africa, El Niño often increases rainfall. Countries such as Kenya, Somalia, and parts of Ethiopia can experience unusually wet conditions. While this can sometimes be beneficial, excessive rain can lead to severe flooding, landslides, and disease outbreaks. The 1997-98 El Niño demonstrated these risks, bringing some of the worst flooding in decades and displacing hundreds of thousands of people across the region. Further south, however, the pattern is often reversed. Countries including Zimbabwe, Zambia, Botswana, and South Africa frequently experience reduced rainfall during strong El Niño events, increasing the risk of drought, crop failures, food insecurity, and water shortages. The 2015-16 El Niño produced one of the worst droughts in decades across parts of southern Africa. Millions of people required food assistance as agricultural production declined and water shortages intensified. This contrast between flooding in the east and drought in the south illustrates just how complex and far-reaching El Niño's influence can be. The Amazon rainforest is often associated with endless rainfall and abundant water. Yet even the world's largest rainforest is vulnerable to El Niño. As global weather patterns shift, parts of the Amazon can experience reduced rainfall and higher temperatures. Rivers may fall to unusually low levels, and vegetation can become increasingly stressed. Drier conditions also raise the risk of wildfire, allowing fires to spread more easily through areas that are normally too wet to burn. Beyond the immediate damage, these fires can release enormous amounts of carbon into the atmosphere. The 2015-16 El Niño demonstrated these risks clearly. Large portions of the Amazon experience severe drought conditions. and wildfire activity increased across several regions. The Amazon plays a critical role in regulating global climate and storing carbon. Any major disruption to this ecosystem has implications that extend far beyond South America itself. Unlike Australia or Peru, Europe does not experience a direct El Niño signal. However, it does not escape the consequences. The additional heat released into the atmosphere during major El Niño events can contribute to warmer global temperatures, increasing the likelihood of heat waves, droughts, and wildfires, particularly in southern Europe. The 2015-16 El Niño coincided with one of the warmest years ever recorded globally, and Europe experienced exceptionally high temperatures as part of that broader warming trend. Russia faces its own challenges. In Siberia, rising temperatures can fuel extreme heat, large wildfires, and accelerated permafrost thaw, threatening infrastructure built on previously frozen ground. During the 2023-24 El Niño, parts of Siberia experienced remarkable temperature anomalies and significant wildfire activity. Further north, the Arctic remains one of the fastest warming regions on Earth. Major El Niño events can add further heat to an already stressed Arctic, accelerating sea ice loss, glacier melt, and coastal erosion as protective ice disappears. Following the powerful 2015-16 El Niño, Arctic sea ice reached exceptionally low levels, demonstrating how events in the tropical Pacific can influence even the most remote regions on Earth. One of the most important things to understand about El Niño is that its biggest impacts do not always occur immediately. The oceans release heat slowly, allowing El Niño to influence global temperatures for months after reaching its peak. This helps explain why some of the warmest years on record, including 1998 and 2016, occurred during or shortly after major Super El Niño events. More recently, global temperature records were broken again during the 2023-24 El Niño period. If the Super El Niño of 2026 becomes particularly strong, some of its most significant consequences may not emerge until 2027. Adding to the concern is the influence of climate change. Global temperatures today are already higher than they were during previous major El Niño events. Any additional warming generated by El Niño is now occurring on top of an already warmer planet. That combination could increase the likelihood of extreme heat, droughts, floods, and wildfires worldwide. What begins as unusually warm water in the Pacific Ocean can ultimately influence weather across much of the planet, making the Super El Niño of 2026 one of the most closely watched climate events in the world.